Mobile living usually means a series of trade-offs. It is compact yet fragile. It gives freedom to move but still keeps you tied to the grid. It has a low starting price yet brings ongoing maintenance costs. But can a design really solve durability, energy independence, easy upgrades, air quality, and running expenses all together, turning something that feels good enough into a whole new standard? If those limits start to fade, how does the market react, and who takes the lead next? Out of that question, the Tesla Tiny House 2026 appears as a next-generation mobile living system. It aims to completely reset expectations for strength, setup speed, comfort, and efficiency. It turns energy management into a core advantage, allows modular growth over time, and lowers the overall cost of ownership to a level that older models can hardly defend. That is the real reason Tesla's concept may completely change the market. If the idea of pushing good enough into a new standard sounds exciting to you, stay with us. Subscribe to AMP Drive and help us reach 2,000 subscribers so we can keep uncovering the real stories behind breakthrough designs. Tap that bell so you get the next deep dive as soon as it drops. Let us begin with the biggest question: how does the Tesla Tiny House remove the usual compromises of mobile homes? It starts by addressing the most frustrating issues of traditional designs. Setting up often takes too long. The frame can twist in strong winds, rain leaks through corners, and thin insulation wastes both heating and cooling. Elon Musk and his team made the goals for this design very clear: fast deployment, strong resistance against high winds, and stable indoor temperature to save daily energy. At the center of this approach is what Tesla calls the fold-and-lock system. When the structure unfolds, it automatically locks itself with 6 hydraulic latches. The stated clamping pressure is 2,500 pounds per square inch, equal to around 17.2 megapascals. That is a huge pressure, and it pushes the shell panels tightly together, making them act like one single rigid frame, similar to how a car chassis is fixed during manufacturing. Because the locks engage automatically while opening, Tesla's design removes the need for precise manual alignment, eliminates many small gaps, and reduces vibration while moving. Wind handling is another key test, and Tesla Tiny House approaches it directly. At 200 km per hour, which is around 55.6 meters per second, the average wind pressure on a wall surface reaches roughly 1,890 pascals, or about 0.27 pounds per square inch. That might not sound like much per square centimeter, but across an entire wall it adds up to serious force. Each square meter of wall carries pressure equal to the weight of about 190 kilograms. For a wall area of 10 square meters, that total becomes close to 1.9 metric tons. Because pressure increases with the square of wind speed, 200 km per hour creates almost double the pressure of 140 km per hour, about the range many current mobile homes are built for. To stay stable under that kind of stress, Tesla uses multiple locking points along the reinforced steel frame and spreads the pressure evenly through the layered panels. This stops a few bolts from taking all the load and prevents warping or joint gaps. The shell itself is a steel sandwich made up of 3 coordinated layers. The outer layer is coated steel with a ceramic finish to resist corrosion and ultraviolet light, giving it a claimed lifespan of about 50 years. The middle layer is polyurethane foam rated as Class A for fire safety, which means that when the flame is removed, it does not keep burning. Tests show it can stop burning in roughly 3 seconds. The inner layer is aluminum of aerospace grade, treated with an antimicrobial silver ion coating that in tests has shown up to 99.9% bacterial reduction. Insulation performance, or R-value, is another major number to consider. The Tesla Tiny House wall panels are about 4 inches thick, around 10.16 centimeters, and have an R-value of 28, while many wooden walls are around R13. That means for the same indoor and outdoor temperature difference, the Tesla wall loses about half as much heat as a typical wall. Thanks to better sealing and high air tightness, total heating and cooling savings can reach nearly 60% in real conditions. Waterproofing is another critical advantage. Many small homes depend on silicone sealant at their joints. Silicone ages under sunlight, shrinks, and expands differently than surrounding materials, eventually leading to cracks and leaks. Tesla's solution is very different. It uses laser welding at key seams to fuse separate steel sheets into a single continuous strip of metal. Because the welded joint shares the same expansion rate as the base material, seasonal heat and cold will not easily create gaps. At the production line, every Tesla tiny house goes through a water jet test at 5,000 pounds per square inch, or about 34.5 megapascals. This is an extreme test that pushes water at very high pressure to find micro leaks before the home ever leaves the factory. Once you combine all these layers and techniques, you get a structure that is sealed, strong, and thermally balanced. Current mobile homes typically handle only around 120 to 140 km per hour of wind and rely heavily on caulking. Tesla's target is around 200 km per hour, similar to a Category 3 hurricane. This gives users real peace of mind when the weather turns rough. Instead of depending on caulk, Tesla's use of automatic locking steel panels and laser-welded seams creates a nearly monocoque shell, stiff and watertight. Even after harsh wind and rain tests, the body stays tight, so stopping during storms feels much safer. Strong insulation allows the air conditioner to idle instead of running hard, making summers less stuffy and winters less energy-hungry, naturally lowering electric costs. Tight sealing also blocks dust and noise, keeping the cabin quieter and cleaner. Compared to hand-built mobile homes with aging sealants, Tesla tiny house clearly stands apart. It offers faster setup, stronger waterproofing, excellent wind tolerance, and lower yearly operating costs. When considering ownership over many years, those advantages add up. Laser-welded seams tested at 5,000 pounds per square inch versus joints held together by aging caulk. After 10 years, which one would you expect to stay dry? Comment, Tesla wins, below if you agree that leak-free longevity matters the most. After creating a solid shell, Tesla turned to another big challenge: how can the home power itself and keep running smoothly anywhere? Living off-grid often means unreliable or missing electrical hookups, so Tesla designed the system to be fully autonomous. The battery had to be long-lived, safe, quiet, and intelligent enough to handle power use automatically. That requirement led directly to the use of lithium iron phosphate cells in the Powerwall 3 mini system. These cells are valued for their stability and safety, showing no ignition even in nail penetration tests. The battery pack is rated for about 6,000 full charge cycles, meaning one cycle each day would equal around 16 to 20 years of service. Partial daily use stretches that even further. It works from -20 degrees Celsius up to 60 degrees Celsius, so it can handle cold mountain mornings or hot desert days with ease. The inverter supplies a steady 5 kilowatts of continuous power and up to 8 kilowatts for short peaks, enough to absorb startup surges from refrigerators, pumps, or microwaves while keeping lights steady and fans spinning. Over this, Tesla added a learning-based power manager that studies your habits, giving first priority to essentials like the refrigerator, lighting, and water pump, while delaying less critical loads such as electric vehicle charging or laundry to times of higher sunlight or spare energy. If the battery charge drops below 20%, it automatically enters a conservation mode that cuts power to non-essential circuits, no need for the user to adjust anything. A small Powerwall Mini rated at 5 kWh with about 80% usable capacity gives around 4 kWh before it reaches that threshold. That can power roughly 950 watts of load for a little more than 4 hours without sunlight. If the solar roof provides between 1.5 and 2 kilowatts at midday, the system runs normal appliances, charges the battery, and schedules heavier loads like laundry during the surplus window. Whether the home is connected to grid power or parked completely off-grid, the inverter balances fluctuations automatically, acting as the energy heart of the house. The Powerwall Mini fits neatly under the floor, measuring about 60 by 80 by 15 centimeters and weighing close to 95 kilograms. This position saves space inside and lowers the center of gravity, which improves towing stability. The operating sound is about 25 decibels, almost silent, similar to a quiet library. That means nighttime charging will not disturb sleep. With everything integrated, Tesla made the entire experience effortless. You do not need to worry about switches. The refrigerator stays cold, water pressure is consistent, lights remain steady, and the air conditioner quietly maintains your preferred temperature. The entire setup behaves like a unified system rather than separate gadgets. Safety, efficiency, smart scheduling, and quiet operation all come together to make the Tesla tiny house a real autonomous energy system. This independence gives owners true freedom. You choose the view, not the outlet. You can also check the links on screen for more about the Powerwall 3 Mini and insulation ratings. Tesla's approach makes technology worth every penny when it supports real-world independence. Once power and comfort were mastered, Tesla looked at another challenge: how to make the home adapt as your life evolves. Over time, needs change. You might need an extra bedroom, a small office, or maybe a greenhouse later on. Normal homes require expensive renovations, but Tesla treats this house like a platform. At its core lies a central structural spine that holds the main steel frame, plumbing, and electrical bus bar. Around this spine, you can attach plug-in modules, bathroom pods, kitchen pods, bedroom or office spaces. Each module connects with just 4 bolts, 2 electrical plugs, and 2 water couplings. Installation finishes in roughly 10 minutes. That means you can change the layout of your home within a single day without hiring large construction crews. Even better, the electrical system supports what Tesla calls hot swapping. You can replace or upgrade the battery while the main circuits stay live. For example, the Powerwall Mini Generation 1, which holds 5 kWh, can later be replaced with Generation 2 having 7 kWh, expected around 2027 or 2028. The swap takes about 15 minutes without shutting anything down. Solar capacity can also grow, from 3 kilowatts to 5 kilowatts, by just adding panels to the same wiring harness. Every module includes its own microcontroller and can receive over-the-air software updates. Updates can improve air conditioning efficiency by around 5%, enable storm mode that reinforces locks and adjusts ventilation, or close the main water valve automatically if a sensor detects a leak. In this way, your Tesla tiny house not only grows in size but also in capability through time. To increase total space, Tesla includes docking ports at both ends of the structure. When a new module is added, the connectors align automatically and the mechanical, water, and electrical links snap together through standard interfaces. Starting from a base configuration of roughly 375 square feet, you can expand it to about 1,200 square feet by adding, for example, a second bedroom around 150 square feet, a small workshop or garage about 200 square feet, or even a greenhouse for homegrown vegetables. This design means you can begin with a small, affordable setup and expand later as your needs grow, just like upgrading memory or storage in a computer. There is no need for demolition, no long downtime, and no massive one-time spending. Tesla even plans trade-in programs for modules and batteries, reducing upgrade costs further. From a market viewpoint, transforming a home into a modular platform changes everything. It extends the life of the product, since owners can keep upgrading both hardware and software instead of replacing the entire house. The resale value also stays high, because newer buyers can refresh modules or systems easily. Competitors will find this approach hard to copy without rebuilding their entire structure around a central spine, standardized connectors, and update-ready software. Imagine having a Tesla tiny house. How many modules would you add in your first year? Would it be a second bedroom, an office pod, a greenhouse, or a workshop? Tell us below in the comments. From a shell strong enough to face storms, to an electrical system that thinks on its own, to a modular design that grows with your life, the Tesla tiny house marks a new standard for mobile living. If these concepts help you see beyond the hype and into what truly works, stay connected with us. Subscribe to AMP Drive and help us reach 2,000 subscribers so we can keep exploring the real engineering behind tomorrow's innovations. Thank you for being part of our journey, and remember to hit the bell icon so you never miss our next deep dive the moment it arrives.